What's up everybody? Welcome back to our channel. If you're new here and you don't know who I am, my name's Eamon. I live in this self-converted sprinter with my fiance Rebecca. She's amazing. She's not gonna make it in today's video, but you should probably check out some other videos and toss a subscribe just for her alone. She's gorgeous. It's just precious. Today I wanted to jump in and teach you guys about electricity. We get a lot of questions about how things work, how big's a battery bank, blah 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 blah. It can get super technical, and when I started this build I started watching a lot of YouTube videos and no one really explained it well, so I hope I can do a good job of keeping it very simple and easy to understand on how electricity works and how we power our different utilities. So let's go. Basically, when it comes to electricity, there's two types, AC and DC, just like the rock band. Anything house related that you would plug into the wall is gonna be AC power. So if you're looking at things like the Vitamix, your laptop, anything that's got like a 3-ended prong like this, that's gonna be AC power, typically 15 or 20 amps. Now, if you're talking about DC, is direct current. Now that would be anything that's in a battery form. So your car battery, the battery in your laptop, the battery in your cell phone, that's always gonna be DC power, direct current. So if you wanna convert those, you need an inverter. So if you look at something that everyone, or typically everyone has, even like a charger, right, for your laptop. This has an AC end, but it's going to a DC battery, so it needs to invert the power. That's what this bulky, chunky thing is. This is a little inverter. Now that you kind of have an overview of DC, AC, now you can break it down into your space, your build. Our van is totally disconnected from the front electrical system, meaning the battery that actually starts the engine. Eventually we will connect that, but I'll talk about that later. So the number one biggest power consumer would be our refrigerator, because typically we're running that all day. Number two would be the Vitamix, but typically we don't run that often. All the LED lights are super efficient. And then the heater. So when it's this cold, guys, it's like -20 here in Canada. When it's this cold, that heater is basically working non-stop. But it's a diesel heater, so it's not running off electricity, but that noise you hear, that's the fan, and it's blowing the hot air in, so that's constantly running. A little bit of a draw. So let's try and break down really simple, I hope you're still with me, on the entire electrical system and how it's designed. Start things off, I've got two 95 amp hour batteries. Those are deep cycle Agm batteries, and they're hooked up in parallel. They're 12 volts, so DC power, you can get it in different voltage. Typically I think it's 6 or 12. I went with 12 because most lights, fans, pumps, run on 12 volt. Heaters, everything's running on 12 volts. So that basically means that you can just jump red to red, black to black, and then you've got 12 volt, you turn on your lights and it works. Basically, our two 12 volt batteries are hooked up in parallel. And what that means is they're both 12 volt batteries, so it doesn't change the voltage, it just doubles the amp hours. So instead of 95 amp hours, it's gonna be 190 amp hours. I hope that makes sense. I went with Agm batteries because it's like low maintenance. It's a sealed type of battery. Be careful, there's different types of batteries. Some of the older style batteries, they actually off gas, and then you run into issues where you're supposed to like drain out this disgusting fluid. Keep it simple, like just get the deep cycle Agm batteries. From there, you need a way to charge your batteries. So there's a few different options in regards to charging. I'm gonna walk you through our system and then I'll explain some other options. The number one option for van life would be solar. So solar is obviously an incredible solution. It's green, it doesn't cost you anything. Once your panels are on the roof, they're just collecting energy from the sun. So highly recommend that. We've got a 320 watt solar panel sitting on the roof at all times. And right now we're parked in the shade and we're still pulling in a little bit of electricity. So huge win. The second way we charge our van is shore power. So we actually just run a line from our house, our office, our friend's place, McDonald's if they've got an outlet outside, wherever we can find it, and it plugs right into our van. Definitely the most intimidating process was trying to figure all this out, but there are a lot of resources online. and typically the companies that I was buying from were pretty helpful. So there are a few options. If you're like not tech savvy at all and you want to do a conversion, I would highly recommend you check out Goal Zero. Our friends, Minimum Millennials, they have a Goal Zero setup and it's awesome. It's super easy. It's basically plug and play. The thing is a battery, it is an inverter. It's really, really user friendly. It's got the outputs on there. The reason we didn't want to deal with that is number one, they're very expensive, but number two is it's sort of limiting. With this, you can kind of keep building upon your battery bank. So, you know, if for some reason we wanted to move into a tiny house or a bigger property, we could take this 2,000 watt inverter and jump it onto a huge battery bank, and that way we're holding on to our investment. Also, I just love the challenge of trying to figure this out and learning it. So here's what we did. On top of the roof, we've got our solar panels, and then it's got two cables that run directly into the brain. This guy here is the brain. This is our MPPT charge controller. Those cables coming directly off the roof, they're going right into this. And that's active. See, that's when that light's not on, it says PV. PV is another little short term for solar panel. So that means that's working. Then over here, you've got your battery. So this is the red and black that's coming directly off the battery line. The brain is telling the batteries, hey, we're low, charge me, and it just automatically kicks some juice into there. Then the last two cables there are running into our fuse box. I'm gonna get to that in a minute. This little friendly guy is what we communicate with. So this is our display, and this will show you exactly what's happening within your system. So basically, if you get this display, always reference the happy face. For like the first month of using this system, I had no idea how it worked, and I just always looked, oh, he's happy, we're all good. Basically, this will show you, that's your panel, this is how much you're pulling down, this is what our system's at. Let's keep that light on. And this is our current load. So load meaning the electricity that we're pulling right now. So things like the lights are on, that fan's on. So right now we're pulling 3.3 amps. I know you guys, if you're new, you don't really know what that means, but that's the total draw of what we're using right now. If I was to fire on the Vitamix, you could actually see that load jump and spike probably up to like 10 amps, depending on how hard I'm working that. Does that make sense? I hope that makes sense. Now that you sort of understand the battery system, how the solar panel is kind of working, I'm gonna jump into our DC. So once again, everything DC would be your heater, your fridge, our electric water pump, the lights, the fantastic fan. That's all of our DC appliances. So all of those DC appliances run into our 12 volt DC fuse panel. All the reds go along the bus along the bottom. All the blacks just basically tap onto the blacks on the top there. And this creates the circuit. So quite literally, that fuse, all a fuse does is connects the circuit and makes sure that the voltage doesn't run over what it's supposed to. So if, for example, my lights started pulling more energy for whatever reason, that 20 amp fuse would pop and just kill the circuit and not damage any of the batteries or any of those systems. So all of your appliances should be fused. That's just the correct way to do it. And then my negatives are running to my negative, my positive is running to the positive on the battery. Not really that complicated. I mean, black to black, red to red as far as DC goes. You guys, you get it? Are you guys like watching this like, shit, I could take on a conversion. I'm gonna do this. Yeah, I mean, it's not that bad. DC power is really, really simple, especially if it's 12 volt. You buy a 12 volt battery, you buy 12 volt lights, boom, you run it in, you're golden. Now let's talk about AC. In order to get AC power from a battery bank, you need an inverter. So inverters come in all different sizes, watts, different companies make them. They're pretty inexpensive, like you can buy them at like a Walmart. I went with more of a high-end inverter, just so that would give me a little bit of flexibility down the road if I ever did want to upgrade systems. So I have a 2,000 watt pure sine wave inverter / charger. And the reason why we got the charger is, like I talked about, this has the ability so that I can just plug into shore power and it juices my system and refills the system, which has been so key, because if it's gray for a couple days, just holler at a buddy, yo, can I plug in? Or if we're at our office like we are right now, I typically plug in every couple days just to charge up the system. To AC power, we don't talk red and black, we talk live and neutral. Live and neutral. Once again, pretty sure that's right. Live and neutral. Live and neutral? Live and neutral. But you're gonna wanna wire it into a circuit breaker, kind of the same kind of concept. Fuse. This is a 20 amp, and then you're running, it's all enclosed in there, but you're running from the inverter into those same 12 gauge cables that go into the outlet. And then you have an outlet, and then you can just plug stuff in. So the way the charger works is pretty simple. Basically, it's got an input, and what I did is I took an extension cord and actually just cut the cable. So you guys see, this is a normal extension cord, but it's got the green, the white, and the black. So the live, the neutral, and the ground. I wired that up and ran the cord right to the back of the van. That's what this cable is. And then I just plug that into another extension cord and run it into a friend's place. It's freezing out there. It will charge the van in like 2-3 hours, which is like so rad. So all of my wires, like I didn't even know any of this before I bought the van. Like I bought the van and started like putting wires in and just like Googling like, how should I wire a van? All of my wires are 12 gauge and I just went everything red and black. So I just bought the van and I started running wires. Okay, that's gonna be my fridge, that's gonna be my blender, that's gonna be my, and was just hoping that that was correct. That is correct, but if you are talking about AC power, you should actually have 3 cables, 12 gauge, a live, neutral, and ground. Ground is typically a green or a brown color. And yeah, you might want to do that ahead of time because in our situation, we had to try and fish up a ground cable, and it's not very fun to do that once you put tongue and groove on the wall. So quickly want to talk about the kill switch. So I put a master kill switch on each end. So for example, if I ever do work on this little system, I can just totally kill this. This is going into my inverter. So if I shut that off, the inverter would totally shut down. And then this is my DC, so check this out. If I shut that off, boom, the whole system shuts off. And then you turn it back on, and everything turns back on. Highly recommend getting a kill switch. This just makes working on your van a lot safer. One thing we did learn and adjusted down the road was that 12 volt power is much more efficient than AC because technically you have to go through that inverter. It just takes more energy to do that. So things like USBs, you should run that off of your 12 volt. USBs are 12 volt anyway, so you know, when we went out and bought this van and started buying stuff for the van, I bought these fancy things on Amazon. And I was like, oh, those are gonna be perfect. You plug your USB there. But if you want to charge your phone, you're running through the battery, through the inverter, putting it into here, which is inverting it again into DC. It's just super inefficient. So I installed this little guy, red and black cable, directly to the battery, and you know, you charge your phone. It just makes a lot more sense. Any of the lights, we ran the 12 gauge wire, you know, obviously behind the wall and everything like that. And then I did this really simple switch design. These switches were like $3, and basically you've got your positive and your negative going in, and then the switch actually just kills the circuit. This is our light switch right at the front door. So as soon as you walk in, that controls those 2 lights, and you can quickly turn those on. And then the back ones, I put on a dimmer, and that's on Amazon as well. But nice to be able to turn the front 2 lights off. Look how dirty our place is. Becca's gonna freak. And then dim and have like a chill zone. That's all I have for you guys today. I hope you found that video helpful and maybe you even learned a thing or two. I hope all my information was correct. I just wanted to keep it really simple and explain to you guys what I've learned. If you have any specific questions, the best place to get me is on Instagram. You can find me here, a.mon, and send me a DM and maybe I can help you with your project. So electricity doesn't need to be that overwhelming and you can figure it out, so just give it a shot. You know, maybe get someone like an uncle or something like that to like oversee you as you're actually hooking up the cables so you don't kill yourself. But yeah, you'll be able to do it. All right, peace. Bye. plan.